All right, we're gonna start with a little warm-up question today. Okay, so yesterday we talked about that you could have anywhere from, with the problems we're doing, 0 to 4 solutions in these systems. So with your group, I want you to see if you can sketch a situation where if a circle and a parabola intersected, how would it look if there were 0, 1, 2, 3, and 4 solutions? See if you can draw all those situations. All right, go ahead. To check them? Here are my answers. Hopefully you have something kind of similar to these, same sort of situation. It might be, you know, like in a different location on the axes, or your parabola might be opening down. But this is how you could get each of those to occur. Okay. When you're looking at the equation, if it's a line, nothing squared. If it's a parabola, one variable is squared, and if it's a circle, it's going to be 2 variables squared. For the most part, we have some other ones in there, but they have similar situations. If it's a circle versus a like ellipse, like an oval shape, it all kind of does the same thing. All right, any questions on this? Okay, great. All right, so we've got a couple more problems we're going to solve, like we were doing yesterday. That's an x squared at the top there. We're going to do 2 of those, and then we're going to see just a couple word problems. I'm going to help you guys get those set up, and that'll wrap up the lesson for us. And then you'll get those quizzes back. Okay. All right, so first one, x squared minus xy plus 5x equals 4. 2x squared minus 3xy plus 10x equals negative 2. Okay, so remember we talked about yesterday, options are substitution or elimination. Substitution would be real nasty here. It'd be very difficult to get any variable alone. So elimination is our option, okay? Then we have to decide, we've got 3 different types of terms here. We have an x squared, we have an xy, and we have an x. And we have got to decide which one to get rid of. Only one of those is a good choice here. Remember, whatever you want to get rid of, you want to be left with all of the same variable only. Okay, it can be different terms, but all x's or all y's. So which pair of terms should I get rid of? So I'm left with either all x's or all y's. The xy. We've got to get rid of the xy, because otherwise you still have an x and a y in the problem. Okay, what could I multiply by to get rid of the xy's? Negative 3 on top would work. Okay, so that's what we're going to do. Negative 3 on top. All right, so that would be a negative 3x squared, a positive 3xy, a negative 15x, and a negative 12, and I'm going to add my equations together. 2x squared and negative 3x squared give me negative 1x squared. Xy's cancel. 10 and negative 15 give me negative 5x. Negative 2 and negative 12 give me negative 14. Okay. All right, now I have a quadratic. I need to solve my quadratic. I want to get it equal to 0. It would be pretty easy to move that 14 over, but then my x squared would still be negative. So I'm actually going to move everything over to the right side, because that'll make my x squared term positive, and that makes it easier to factor. All right, so it's going to be 0 equals, if I move the x squared term over, it's positive. Move the 5 over, it's positive. The 14 is still negative. If you did move everything over to the left, that's fine. I would just recommend dividing through a negative 1 then to make it positive. You can just do that in 2 steps. Okay, this is not a bad factoring problem. Give me 2 numbers that multiply to negative 14 and add to 5. 7 and 2, which one's negative? Good. Okay, so positive 7, negative 2. So I have 2 answers for x. X is negative 7, and x is positive 2. All right. Once I have those, I can plug them back in to either original equation to get the y's that go with it. I'm going to use the top equation just because it looks less nasty, but either one works, okay? So I'm going to plug x into the top equation. That's going to look like negative 7 squared minus negative 7y plus 5 times negative 7 equals 4. All right, then a little bit of simplifying. Negative 7 squared, that's 49. Plus 7y minus 35 equals 4. It's looking better. 49 minus 35 gives me 14. Plus 7y is 4. Subtract 14, that's negative 10. divide by 7, negative 10 sevenths. So not super pretty, but that's okay. Our point is negative 7 and negative 10 sevenths is our first answer. Okay. Same thing with the 2 now. I'm going to plug it back into that top equation everywhere I see an x. So 2 squared minus 2y plus 5 times 2 equals 4. 4 minus 2y plus 10 equals 4. 4 and 10 give me 14. Subtract 14 gives me negative 10. And this one works out nice and pretty. Y is 5. So the other solution is 2, 5. Remember when you do Math Excel, you might have to type answers, or it might just say how many solutions are there. And even if you made a little algebra mistake, you hopefully still would get 2 solutions. So those are the nice ones. Okay. Any questions on that problem? These ones aren't too bad because you don't. I think the substitution can get a little messy with like the foiling and the factoring and stuff, and it's pretty obvious what you have to get rid of. You've got to get rid of the variable that stands out. All right, so the next problem, we're not going to go through the whole thing. I just kind of want to talk about the first step. Okay, this is similar to the last one. We definitely don't want to use substitution. We're going to use elimination. What would you need to eliminate here? What would you need to eliminate?
Y squared.
Yep, you'd have to eliminate the y's. And what could we multiply by? Negative 4. After that, then, you're going to have a quadratic that's got x's in it, and you're going to factor it, solve for x, plug them back in, and get the y. So same as the previous problem, okay? So the variables might look a little different, but it's the same sort of strategy. When they get pretty big like this, pick the one that stands out, that's a variable that's unlike all of the other ones, okay? Any questions on that? Okay. So last 3 problems today are some word problems. We'll solve this first one, but we might not solve the other 2. We'll see. All right, so it says, the area of a rectangle is 63 square feet, and the perimeter is 33 feet. What are the dimensions of the rectangle? Okay, so we have to write 2 equations, and then we have to solve our equations. I would draw a picture to start, though. Okay, here's my rectangle. I know the area is 63, and then I know the perimeter, which is going to be on the outside, is 33. Okay. What do you know about sides of a rectangle? Good, yeah. So 2 are the same. Which 2? Okay, so you can call them whatever you want. X and X, Y and Y. If it was a square, it would be all X's or all Y's, whatever you want to call them, okay? So now with that, you should be able to write 2 equations, okay? So let's start with the perimeter equation. The perimeter is 33. How do we get 33? Right, so can we condense that, make it a little prettier? Perfect. 2y plus 2x. 2x plus 2y, doesn't matter. Okay, so that's a perimeter equation. The other equation we need to write is an area equation. So again, I can start with my total and work backwards. The area is 63. How do I get the area of this rectangle? X times y. That's it. And then we need to solve that system. To solve that system, you can either use substitution or elimination. Elimination is going to be tough here, though, because there's no like terms between the 2 equations. We got an x term, we got a y term, we got an x, y. They're all different. So you pretty much have to use substitution here. Let's get like the x or the y in the bottom equation alone. Let's get the x alone. So if I got the x alone, it would be x equals 63 divided by y. I have to divide both sides by y. Okay. Then I'm going to plug that into the top equation for x. So that looks like 33 equals 2y plus 2 times 63 over y. Okay. What is 2 times 63? 126 over y. I need to be able to put those terms together, what do you need to be able to add fractions together? Common denominator, what's the common denominator? Y, so that second fraction is good. The first fraction, I'm going to multiply both the top and the bottom by a y over y. Okay, you're allowed to multiply by whatever you want as long as it's something over itself, because anything over itself is equal to what? 1. And does multiplying by 1 change anything? No. So I could multiply by 27 over 27. It wouldn't help me here, but I could, and it's going to make my equation the same still. All right, so that's 33 equals 2y squared over y plus 126 over y. And then one more thing I could do to make this a little bit nicer is I can multiply everything by y. That'll get rid of my fractions, my things completely. And actually, I probably could have done that in the last step too if I wanted to. Just multiply through by a y. Okay, so that'd be 33y equals 2y squared plus 126. And there's the quadratic that we're looking for. Okay, so I'm going to get it equal to 0. 0 equals 2y squared plus, no, minus, if I put my terms in order, minus 33y plus 126. And then we can factor that, or quadratic formula. And that'll solve for y. Once we have y, it's going to be one step to get to x. This one you might be able to guess and check, not too terribly. You know your first terms have to be a 2y and a y. That's the only way we're going to get a 2y squared. You also know if my last term is positive and my middle term is negative, these both have to be negative. That's the only way for that to happen. Okay, so do you know what it is? 21 and 6. Okay, so if I put 21 here and 6 there, that should work. Okay, so 21 and 6 give us that 126. My outside terms are a negative 12y. My inside terms are a negative 21y, negative 12y, and negative 21y, giving negative 33y in the middle. If you don't want to guess and check like this, remember you could always use the grouping method like we practiced yesterday, or quadratic formula. Quadratic formula will take you straight to the two answers of y equals 21 over 2, or 10.5, and y equal to 6. Okay. Once you have y, I would plug it back in that really easy bottom equation. We have 63 over y will give us x. So 63 over 6 gives us, miraculously, 10.5. And 63 over 10.5 miraculously gives us 6. Mathematically, there are two answers. 6, 10.5, and 10.5, 6. But aren't they the same answer, the dimensions of this rectangle? It doesn't matter which one's the length and which one's the width. Either way, I'm going to get a perimeter of that and an area of that. So any one of these would be fine if you list it as a point. More than likely, if you're doing this in Math Excel, you're just going to be, instead of listing it as a coordinate, listing the dimension. So you'll say one side is, it's all in feet here, one side is 6 feet and the other side is 10.5 feet. Okay. Any questions on that one? That's the only one we're going to like really solve. The other ones we're going to practice setting up. Okay, last two problems then. Let's practice setting these up. It says the area of a rectangular pasture is 8,750 feet. By the way, I got this question from Math Excel. You will see a Math Excel question like this. The pasture is divided into 3 smaller pastures by 2 fences that are parallel to the shorter sides. The width of the 2 larger pastures is the same, and the width of the smaller pasture is half that of the others. Find the dimensions of the original pasture if the perimeter of the smaller pasture is 190. Okay, we absolutely need a picture for this. There's a lot happening. All right, so it says the area of a rectangular pasture, I'll label my area, 8,750. Okay, and we'll come back to that later. That's going to help us write one of our equations. Big rectangular pasture. Okay. It's divided into 3 smaller pastures by 2 fences that are parallel on the shorter sides. Okay, so something like that. Divided into 3 sections, those fences are parallel on the shorter sides. So I have 3 small rectangles. The width of the 2 larger pastures is the same. So let's say these are the 2 bigger ones, and they are the same. Whatever they are, they're both x. The width of the smaller one is half that of the other. So what could I label that other section at the top? 0.5x. Okay. We do not know how tall they are. It's going to be different, likely, but they're all going to be y. Okay. It says find the dimensions of the original pasture. So that's going to be the big one across. So your answers are going to be whatever this length is and this length is at the end. But as soon as you get x and y, you can get those pretty quickly. If the perimeter of the smallest pasture, this guy here, is 190 feet. Okay. So again, the perimeter and the area are going to give us the equations. Let's start with the perimeter. So the perimeter of my smaller one was 190. So 190 equals, how do we get to that 190? Right, so there's going to be two y's on the sides, and then you have a half an x on the bottom and a half an x on the top. So if you need to write out half x plus half x, you can, or we just know that's going to be plus x. So that's going to be those four sides all added together. Okay, there's my first equation. Nothing too crazy, and actually that one, very easy to get the x alone. So substitution won't be terrible in this problem. Okay, my other equation is going to come from the area. My area was 8,750 feet, and that was of the original pasture. That's the big rectangle now. So 8,750 equals my length across. What's my total length across the top there? 2.5x times y. That's your second equation. So again, if I were going to solve this, and it'll be kind of similar to the last one we did, I would get a variable alone. This variable looks really easy to get alone. So I would get x by itself, and then whatever that's equal to, I would plug it into this bottom equation. It's going to give you a quadratic. You're going to have to solve the quadratic. If there's a decimal, you don't like the decimal, you can use the quadratic formula. Once you have one, you plug it back in and get the other. Just make sure you're very careful in Math Excel. This question is not asking for x and y. It's asking for the dimensions of the original rectangle. So one of those is y, okay? But this isn't x. This is whatever 2.5x is. So you have that extra little step at the end when you type your answer in. That can be frustrating if you don't see that. Okay, questions on that one? All right, cool. We just got one more. All right, a group of students chartered a fishing boat that would cost $960. Before the date of the trip, 8 more students joined the group and agreed to pay their share. The cost per student was reduced by $6. Find the original number of students and the original cost per student. What are the two things I'm solving for here? Are my variables? What am I solving for? Okay, original number of students, original cost per student. I'm going to use S and C, but you could definitely use X and Y. Okay, that way I just remember which one's which. Okay, so I need to write two equations because I have two variables. The first equation is going to come from that 960. That's our total, okay? So if it costs 960 total for all the students to go, that total would be the number of students times the cost per student. So for example, there might be 96 students and it's $10 per student. That would give me 960. There's other ways that that could work, but that could be a possible answer. Okay. Now, when more students join, the cost of the trip does not change. It's still $960. But more students went, so the cost went down. How many more students went on this trip? 8. So the students are going to increase by 8. And what happened to the cost? Went down by 6. Those are your two equations. Again, I would probably use substitution here. I would get either the S or the C alone on the top and then plug it in the bottom. There will be foiling. There will be factoring. Okay. The good news here is, can S be a fraction? S cannot be a fraction. So it's whole numbers and there's no negatives, right? Nothing can be negative in this problem because it's number of students and cost. So pretty sure you could guess and check your way through this one if you really needed to, just because of the type of number you know you're going to get as an answer. But it's also nice to know that your answers are going to be reasonable when you look at it, okay? All right, so that's all we didn't finish up yesterday from 8-4. Just a couple word problems in that last little situation we need to see. All right, so homework. You guys finished your 8-2 last night. 8-4 is due on Monday night, and you guys have the rest of the period now. You've got 25 minutes. You can work on that assignment. On Monday, we are going to be doing an escape room, solving systems, a little extra practice, and opportunities to earn a ticket. Okay. Then you guys will have that on Monday night. On Tuesday and Wednesday, we are going to review for your test. Oh no, I take that back. On Tuesday and Thursday, we're going to review for your test. Tuesday, we're going to review for the first part. Wednesday will be the first part. Thursday, we'll review for the second part. Friday will be the second part. The test review, the solutions to the test review, and extra practice are already in Polaris for you, all of it. I will give you the hard copy of stuff probably Monday after the escape room. But if you want anything early, if you want to start looking ahead, if you're somebody that needs a few extra days just to get everything processed, you can do that. I'm going to give you back your quiz. This quiz and the one that we did with the groups last week or the week before is 5/6 of the material that's on your test. Except for this section that we just finished right here, everything else is on those 2 quizzes. So I would highly encourage you to keep those quizzes, know what mistakes you made, because it's not going away. It's coming back on the test, and it's going to count a lot more on the test next week. Quizzes are only 12.5% of your grade. Tests are 50% of your grade. Homework is only 12.5%. Tests are 50%. So that means the test you take next week will be 2/3 of your grade in this class after next week. Okay, welcome to college. Tests count for a lot. So your grade is whatever it is right now, but that can fluctuate either way after next week. This test is big, so you want to make sure you're practicing with the Math Excel, all that stuff. All right, last thing I have for you. Let's call this an exit ticket. This is due when you come to class on Monday. Okay? Work on it now with your groups if you want to. That's fine. Try it. Okay. You guys can work on this. You can work on Math Excel, and I'll get you back your quizzes. I'll do cell phone lotto. The rest of the period is yours. You all have the same questions for those 5. Oh, you're talking about Math Excel. Never mind.
Yeah, I have one.
Oh, how nice that we just went through that. How convenient.